Welcome to the Browne Report with State Senator Pat Browne, a program designed to highlight the issues and concerns that matter most to the residents of Lehigh, Northampton, and Monroe counties.
Hello and welcome to the Browne Report. When you think of Pennsylvania manufacturing, you think of things like steel and textiles and energy. But now something is very clear to us, that Pennsylvania is becoming more adept in unique manufacturing. But for the Lehigh Valley, that's been something that's been long-standing for generations. And one of those unique manufacturers here in the Lehigh Valley is a company called Allen Oregon, a company and a name that everyone who's viewing today will definitely know and recognize. But we will have an opportunity today to tour the plant and to see how this product that's sold worldwide and is well known throughout the world is made here in the Lehigh Valley from start to finish. It's a great opportunity for us. I'm very honored to be here, and I look forward to taking you through the facility. Thank you. We're now inside the facility. We're here with Steve Markowitz, who's the president of Allen Oregon Company. Stephen, thank you very much for having us.
My pleasure.
This organization, this company, has been a fixture in the Lehigh Valley for a very long time. Why don't you give us a little rundown of the history of the company?
Yeah, the company was started really before World War II by my father, who was a Muhlenberg College student at the time. And he wanted to come up with a way of using the latest technology to produce organ sounds. At that time, they were produced by pipes, wind-blown pipes, and then there was the Hammond organ. He decided that he was going to make an electronic organ that was going to sound like pipes, and that's how it all started. Okay. After an interruption for World War II, he started the company downtown Allentown, Pennsylvania.
Where was the company downtown in Allentown?
Well, a couple of smaller locations, but it was on near the 8th Street Bridge for quite a few years till 1953.
Okay, all right. And he moved to Macungie. Why? Why did he decide to come to Macungie?
Well, there was a couple of reasons. First of all, there was a facility available. There was a silk mill that was being sold, which is the original part of this building. And also because there was a fairly good workforce availability out here with good work ethic.
Okay. We're standing in front of, I guess, a historical piece here.
Yeah, my father was a gentleman farmer, and he liked to collect wood samples from his farm, and this organ was made from wood samples that he actually chopped down in his farm.
I don't think I've ever seen, usually you see black ivory in the, on the keys here, and this seems like it's pretty unique rather than black ivory.
Yeah, oftentimes we'll use a black acrylic for these sharps on the manuals. And this one here, actually, we use some of the wood that he had cut down from a farm near Linville, Pennsylvania.
Okay, and this has been a family business since it was founded.
It's been family managed for some period of time. We were a public corporation. We went private in 2006.
So I did know the company went public. Why did you decide to come back to a private company?
Well, the government came up with something called Sarbanes-Oxley.
Okay.
And that would have been quite a disruptive force in our business and not very productive.
Okay.
So that we decided at that time that being a public company was against the interest of the company and its employees.
And sometimes even the best intentioned laws don't fit for some circumstances.
Yeah, this is a fairly small company in the scope of things, and that law would have created hundreds of thousands of dollars of expenses for us that we just couldn't justify.
So the unintended consequences of a law that came out of a worthwhile purpose. So I can definitely understand that.
That's correct.
Because in the end, it's going to come out of your workforce, it's going to come out of your profitability, and the company's been successful for so long, you have to consider that.
That's correct. So that was actually the major reason in 2006 that we finally went private again.
Now the Allen organ itself is a proprietary invention of this company. It's not something that was taken from somewhere else.
That's correct. My father got the first patent on a stable audio oscillator in the 1930s. We ran on analog technology until 1971. In 1971, he took a very risky move and did a joint venture with then North American Rockwell. And as a result of that, in 1971, this company introduced the first digital musical instrument in the world utilizing a technology that we today call digital sampling. And it's the basic technology used in any digital tone generation today.
Where do you sell your products?
We sell our products worldwide. The lion's share of that's North America, but we have a big market in Europe and Asia.
You don't have a retail presence, though. You sell right out of here?
We sell to independent retailers who then resell our products.
Okay. So you have a list of retailers throughout the world who sell the products that come out of this facility.
That's correct, and in fact, in 2 weeks we're having an international sales seminar where they're all going to gather here in our sales building, and we're going to go through some new products and techniques for going forward.
One of the most exciting parts of this opportunity for me is to see how things come from the base materials to what we see here. So why don't we take the tour into the facility and see how you make your products.
Sure.
Thank you.
This is the manufacturing facility, and at this end of the plant we're starting with the electronic sub-assemblies.
Okay.
This room here is closed off because it has its own pressurized humidity system and temperature system, because we put together in there advanced PC boards, surface mount and through hole, and I'd be glad to show you inside there if you'd like.
Okay. This
is sort of a clean room, and you notice you walked in on a mat there where it took the dust off your shoes.
Okay.
And you'll notice it smells a little different, the atmosphere is a little different, it has its own cleaning capabilities. And there's various processes that are going on in here. Here you have wave soldering machines, and this is used for the through-hole technology, basically.
Okay.
Where circuit boards go through a bath of solder inside of here, and there are many connections, hundreds made at a time. Those are molten solder. Now you'll notice there's 2 lines of solder machines, and that's because there are different regulations in different countries concerning how much lead may be used in the process. And one of these lines is a lead-free process, and one of them is a leaded process. So circuit boards like these will go through these machines and get soldered with multiple solder joints being done simultaneously. Okay. What this gentleman is doing here with that pink liquid there is he's putting a solder mask on so that the solder process does not go on certain items of the board where you don't want it.
Okay.
And that's what's happening there. There are many tasks occurring here with these handwork, from inspection to putting in parts that cannot be placed by machine. What we're going to do now is go and take a look at a advanced circuit board. This one happens to be used in our organs.
All right.
And what you have here is DSPs that do the tone generation. And all these little things in here are components that are placed by surface mount machines that we'll now see. And this is pretty high-tech stuff.
And this would be specifically for an organ, this circuit board?
Yeah, this is a tone generation system for one of our organs. Okay. That's correct.
Okay. Your suppliers, where you get the materials to do your work, is it, are some of the suppliers local? Are you able to draw from the local area for that?
Not for the electronic supplies, although the distributors of electronic components might be local. The raw circuit boards, there are very few made in this area anymore.
Okay.
There's some in the West Coast and some outside the United States. Components, to a great extent, unfortunately, are made in outside the United States. Okay. There's a great deal of advanced equipment in this room. Here's an example of one. This is a piece of X-ray equipment, and that's needed because some of the connections for a device called a ball grid array actually occurs underneath the circuit where the eye can't see it. You need to make sure that solder connection for hundreds of parts have made, and this is an X-ray equipment using the same technology of X-rays in a hospital to allow you to see what's going on underneath what the naked eye can't see. The other thing that occurs with these small parts is, in the old days, meaning 10, 15 years ago, you would have people inspecting by the visual eye, but these parts are so small now that you need cameras and robotics to inspect. So what this person's doing here, she has a circuit board in there, and she may be training it now, or she may be inspecting it, and the cameras are actually automatically checking all the parts to make sure the proper ones are in the proper polarity, with the proper solder connections, and she's able to read those photos where those dots are and where those squares are to make sure those are not really a problem.
As far as the coming up with the technology to advance your product, is the technology, the research and development done here for that?
Yes, there's 2 types of research and development. One would be the research and development for the tone generation. Okay. Yes, that's done here with our engineers. Okay. The technology and the R&D done for manufacturing, which is actually going on right now, that occurs inside this room with manufacturing engineers. Okay. And right now, every time that thing's moving, cameras are taking a look at things and making sure they're in order.
Okay.
This area here is probably the highest tech area inside the circuit board manufacturing. Today, components are surface mount. Some of those are so small you can hardly see them, and we're going to see a machine here, an insertion equipment, automatic insertion, that's placing these parts. Is this machine running?
He's doing the first piece right now.
Okay.
Put the board in.
Okay, what this gentleman's doing here is he's putting solder paste down on the board.
Okay.
Solder paste is what we know as solder. And with stencils, he's putting it only on the part of the board where we want the connection to make. Once he rolls this paste, which is going to occur inside this machine, that paste will then be on this board in a proper location, and then we have a certain period of time that we have to place the components and get them in an oven so that we could solidify their connection to the circuit board.
The machines that you use, are they probably manufactured here, or you have?
No, the main line that we use here is actually from a Scandinavian company.
Okay. They're used for similar reasons, for multiple uses of the same circuit board, or for your products? Are they made specifically for your product?
No, these machines can manufacture any circuit board.
Okay.
And while it could be for our musical instruments, it could be for another company that we build parts for. And what's occurring here, this is an older line that we use for smaller pieces.
Right.
It's pulling little individual circuits off of these reels and placing them in the board where they belong. This machine here is capable of placing 20,000 parts an hour. It has intelligent feeders that do the inventory control, and when that board is finished, it then goes into an oven, which is multi-stage oven.
Okay.
And what it does there is it heats the board to the appropriate heating in different locations. This one happens to have 6 zones, and then when it comes out of here, that board is finished. Finished as far as manufacturing, but not as far as test and confirmation that the quality's been done. Okay. That has to be completed, and then it's ready to go.
You could use this facility to build circuit boards for, and I guess you said that outside, for other uses somewhere else.
Yes, we have a fairly sizable business that we supply boards to manufacturers of all sorts of equipment.
Okay. It allows you to diversify your product line in terms of the success of the company.
That's correct. And we've noticed that there's been a movement back from Asia, especially for smaller runs. And that's the kind of thing that we do, small and medium runs.
Is this an area that, in terms of workforce and access to your materials and supplies, is an area that continues to be competitive for you?
Yes. Yes, it is. Yeah, we're fairly good at doing competitively small and medium-sized runs.
In your workforce, do you mostly draw from the local area for your workforce? Are you able to do that?
Yes, yes. Some of the people come with specialized training, and some of the people we train ourselves.
Okay.
In this room here, we're going to go down this way where there's a cabinet being assembled. The wood that is cut in the compartment before this, which we'll see next,
all right,
is ultimately put into a console by a cabinet maker. Excuse us. Here you have a console, an organ console, that is being assembled by one gentleman, and each part is serial numbered, and it's fine quality furniture made of butcher block hardwood.
Okay. And is there a particular type of wood that you need to use?
There are 2 main species of wood that we use on a standard basis, oak and walnut.
Okay. Has to be a hardwood.
Yeah, we use a hardwood. In the inside here, you'll see there's a bass core.
Okay.
And you'll see it's made out of various particles. And this is not particle board, it's actually solid wood. And it's made as butcher block technology so that it will not warp.
And the wood itself, the type of wood, has something to do with the harmonics and the sound of the...
No, not anymore.
Okay.
In the speaker cabinets it might, but mainly it's for strength and beauty.
Okay. Anytime you have an all wood cabinet component, that is high quality and probably high price too.
Yeah, some of the things I'm going to show you in the next department are some techniques we've used to offset some of the raw materials cost by coming up with more efficient ways of producing it.
The raw materials as far as wood, is that something you can get from Pennsylvania, or do you have that shipped in from somewhere else?
That generally comes from other sources, and that's become a little bit more problematic. As you know, most of the furniture companies have left the United States,
right,
and they went to Asia. And as a result of that, the suppliers of wood have had some challenges in this country.
Okay.
So it's lessened the sources of wood that we have available to us.
The percentage of the cost of the finished product that it relates to the wood, how much is that? Is that a significant cost?
Oh, it could be 20 to 30%.
Okay. All right. Well, it's beautiful, beautiful furniture.
Thank you. In this area, the raw wood is cut.
Okay.
This gentleman here runs a CNC router, which actually can cut on the XYZ plot in 3 dimensions. What he's doing is taking a square piece of wood that happens to be used in one of the speaker cabinets. There's a program done in our drafting department, which is in the machine. He puts it in a fixture, and then the machine does all the work. The machine does it perfectly accurately and reproducible and efficiently. And this is one of the techniques I was talking about in the previous department that we use to ensure that we can continue to supply high quality cabinetry at prices people can afford. You'll notice that this is probably the dirtiest area of the plant. There's no dust in the place. And that's because all the dust that machine is creating is then collected, and then it is moved to some other recycling use.
You had mentioned when you're making the circuit boards, you're able to apply that manufacturing to other uses. Do you do any of that with your cabinetry, or is it just for the organs itself?
Most of the cabinetry is for the organs itself.
Okay. All right. The workforce that you have, how many total employees do you have working at the plant?
About 200.
Right. Do you experience any? We had spoken to one of your employees that's been there for 50 years. What's the average in terms of tenure of your employees? What's the average?
I would say it's 20 to 25 years.
So they're very loyal to the company.
Yes. And that gives us a lot of advantages on quality and of our product.
Absolutely.
That these people that we put so much training into, that they stay here.
They have the experience to continue putting together your product.
Next week, there's a new machine coming in that will be replacing that large green machine there. One of the challenges that you have as the wood has changed, as I said, a lot of it has gone to Asia. So some of the quality of the woods and the veneers that we get today have decreased.
Okay.
They've gotten thinner. So we have a new advanced sanding machine coming in that will enable us to sand these veneers quickly, evenly, and without sand throughs.
Okay.
So again, it's another example of using more advanced technology to offset some of the problems of the changing world.
Is it possible to utilize the equipment in here for a lot longer period of time than you do in the circuit board area, just because it's a more traditional part of manufacturing?
And that's a very good point. The answer is definitely to that.
Yeah.
Where a machine in the circuit board area, if it lasts 10 years, that's a good usage. Some of these machines have been here for decades.
Yeah.
Down in this area, we have the raw consoles that were put together up in the cabinet shop.
Okay.
They're waiting to go down into the sanding area, then ultimately the finishing area. All the parts that were manufactured up in that upper end of the factory are here now with their organ. All those circuit boards that you saw are down at this end of the plant. And they all get kitted at this end of the plant to ultimately end up in the final assembly area.
How many are you able to, of these products here, are you able to manufacture in a day here?
We make about 800 a year.
Okay, all right.
The reason you can't say what you do per day is because there's different sizes and complexities.
Changes. Yeah.
A typical organ could take 6 weeks to go through this plant, but some of the big complicated ones could take 6 months to a year.
Is that right? Okay. And in terms of the difference, when you talk about a basic model as opposed to a more complicated one, the relative price point on that, what would that be?
Well, we make organs that retail for just over $10,000, and then we make organs that sell for hundreds of thousands of dollars.
Is that
so
right?
it's a huge difference.
Now, if you had you have a typical place where hundreds of $1,000 organ would go, would that be in a church or?
Oh yes, that would be a church, maybe a concert hall.
Okay, all right.
This is the final assembly area, and what happens is the organ consoles that came through finishing, they have some prep work done to them, and then all of those advanced electronics come together. You can see a kit for this organ right here, where all these parts that are going to go into it are ready to go, and one person will take these kits and assemble them before going into final test. This plant has something that's very unusual in that it's the antithesis maybe of the virtual company. Today, many companies don't manufacture anything. They buy from third-party suppliers. We manufacture everything here, from the wood cabinets that I showed you, to the circuit boards, to the sheet metal, to the keyboards. Everything gets made here. So, in a way, you might say that we were a dinosaur, or we're very advanced today, depending on what end of the cycle you're on.
It gives you a lot of flexibility.
The biggest advantage is flexibility, and the second is quality. If you're a virtual company, you have to commit to thousands often of parts the same way.
Right.
By making them in smaller quantities in our facility, we have control over quality, and we can make changes on a dime, which is what you just alluded to.
A lot of the products you sell are in model form, and you do a lot of special order for them.
Both.
Okay.
And that's a complexity too. If you're going to make everything in model form, it's easy to plan. Oftentimes we begin a product in model form, and then some customer comes to us and says, hold up, I want to change it. So it gets customized, and that's a complicated process.
When you talk about your modeling, is it something you update on a yearly basis? Do your models change a lot, or is it pretty standard?
The models might change every few years. However, the options that are available for them and what customers want is almost infinite, and it changes all the time. Here's an example of a console the way it comes down here. And as you can see, it's just sort of a raw wood console, and it's got some things here, ties for holding the wiring, but otherwise there's nothing here. This will be assembled by one person. A small organ like this, within a day it's assembled and it's completed. A larger one could take days. As we go down this line, you'll probably see organs in various conditions. Here's one that's just about completed. It's just about ready to go to final test. And some of those components that you saw on the upper end of the plant, we have circuit boards and sheet metal and power supplies and amplifiers. They were all made in the upper end of the plant, and now they come together into a musical instrument.
It's amazing how advanced that is. When did these machines first go to the circuit board technology? How far are we looking back there?
Well, when in the 60s, the raw... The really antiquated circuit board started, where we actually took Bakelite, we drilled holes in it, and we put the individual components like transistors in it and made a circuit board.
Okay.
In the 1970s, those lines were formed on, etched on it actually, but there was through-hole technology. Beginning in the late 80s and the early 90s, then we went to this very advanced surface mount technology.
Who are your major competitors and what you do?
Our major competitors, we have a competitor over in the West Coast that's owned by a Japanese company,
okay,
and we have some European competition mainly.
Okay.
And as you can see, there's different finishes here that will actually match a custom finish of a sample that a customer will supply. We've made organs that are gloss finishes, like a shiny piano. We've painted them different colors. That's an infinite characteristic in itself.
In terms of your customer base, is it what percentage is it institutional, commercial base as opposed to individual base?
I would say about 80% of our business is from institutions.
Is it? Okay.
We, however, have built organs for famous individuals. We built a large organ for Billy Joel a few years ago.
Oh, did you really?
So the piano man plays the organ now.
Yeah, that doesn't something I would picture. But,
yeah, well,
as long as he's buying your thing.
That's right. Absolutely. This is our final test area. After the organs come through final assembly that we were just at, they come through here and they go into a room where a musician, technician will go through the organ and make sure that everything's operating properly. We'll load the software that's required for it,
okay, so
that when we ship this organ, the installation can be a smooth process. If we go into one of these rooms here, we'll see what happens in a little bit more complicated installation.
Okay. So you actually have musicians on staff.
Oh, yes.
In order to,
yes,
in order to test these.
In fact, tonight we're going to have a concert over in our Octave Hall where the organist of the Wanamaker organ is going to be playing a concert, Peter Conte.
Oh, okay.
This organ here is interesting at a couple levels. First of all, you'll notice it's a two-tone finish with white on the outside, a colonial finish, and dark on the inside. That's typical of some southern churches have a history of that kind of look.
All right.
And the other thing that makes this thing interesting is if you take a look at this circuitry over here, this tells me that this organ is actually going to be hooked up to the pipes that are already in the church.
Okay.
Many times there's a pipe organ in a church that members of the church and families that originally might have donated that organ want to maintain for musical reasons as well as emotional reasons. So we actually produce a technology that our consoles with our digital voices can also be hooked up to their windblown pipes, and that's what this subassembly is right now that's being looked at. So this organ will play the digital portion, it'll play the pipe portion, and it'll play newer sounds that you can get through what's called MIDI, where we have a device that enables you to add any sound to the organ you want, including, for example, a touch-sensitive piano.
So this would be going to possibly some southern church.
Well, let me see how far off I was. Yes, good guess. It's going to Memphis, Tennessee, in fact.
Okay. And this was a special order by that church.
Oh, yes. This is a special order where they approved the finish, and they told us where they wanted the finish applied. You can notice that it's two-tone, and so there's choices that had to be made there, and that's special for the church. And this is a custom interface for the pipe organ that will only work for theirs.
Do they do that special ordering as far as their needs directly to the plant or through the retailer?
Through the retailer.
Okay.
The retailer would be the interface for us, and then we have some specialized people that work with that retailer to create this custom configuration. This
impressive.
product here probably took 4 to 5 months to build once we received all the material on the order.
And if you had to take a guess as far as what the customer would be paying for this, what would that be?
That would be hard to tell.
Okay.
I don't know the answer to that because of this custom work.
Okay. Well, it looks like it's, given the intricate nature of the machine and the technology, it's got to be a significant purchase.
Yeah, this is a large purchase, and I'm also taking a look. These are the speaker cabinets going to go with this organ. Again, the technician set this thing up so that he could listen to it through the audio system that the church is going to use.
The speakers themselves are made here as well?
Oh, yes.
Okay.
Yes, we make the speaker cabinets, and the speakers are custom made to our specification.
So you can have the speaker capabilities being used, I guess, not just for the use of the organ, but with other stereophonics or other uses as well, couldn't you?
We could, and in fact, we have a specialized usage that we do use. We have special input devices that allows the church to put other musical instruments through our audio system.
Okay.
So, yeah, that's one of the things that we do.
All right. Well, that's great. Well, Stephen, I wanted to really thank you for the opportunity to be here. This is something that I've wanted to do for a very long time. I've known of Allen Organ, of course, my whole life, and the quality and the products you put out in the marketplace are legendary for the Lehigh Valley, and it's a real honor for me to be here, and I wanted to thank you for taking me through, and thank your employees for us as well.
I will, and thank you for letting us be a part of this show.
Thank you. Well, that's all the time we have for our tour. I want to thank Steve Markowitz for taking us through, the president of Allen Organ. It's a tremendous facility and a great example of manufacturing here in Pennsylvania. If you have any questions about the show, please visit our website or visit our district office. The phone and the website will be on the screen immediately after the show. But to end the show, we have a special treat. We have one of the employees of Allen Organ who will close our show with some great organ music. Thank you again, and join us for another edition of the Browne Report.